Jai Hind all of you. Today we will see some numericals. A ray of light incident on an equilateral glass prism shows minimum deviation of 30 degree. Calculate the speed of light through the prism. So here the prism is an equilateral glass prism. So what is the angle of the equilateral glass prism? That is A equal to 60 degree. It shows minimum deviation of 30 degree. So we can note it as delta m. Minimum deviation is represented by delta m, that is equal to 30 degree. So you need to calculate the speed of the light through the prism. So what is the relation between speed and the refractive index? You know that n equal to c by v. So first you want to calculate the refractive index, that is n equal to sin a plus delta m by 2 divided by sin a by 2. Then we can substitute the values. Sin 60 plus 30 by 2 divided by sin 60 by 2. So sin 60 plus 30 by 2, that is sin 45 divided by sin 30. So what is sin 45? 1 by root 2. Sin 30 1 by 2. So we get root 2. So what is the value of root 2? That is 1.414. So that is the refractive index of the glass prism. Then you want to calculate the velocity. So v equal to c by n. From the formula n equal to c by v. So we can substitute the values. C equal to 3 into 10 raised to 8 divided by n equal to 1.414. So we will get the value 2.12 into 10 raised to 8 meter per second. Next question. A ray of light passing through an equilateral triangular glass prism from air undergoes minimum deviation when angle of incidence is 3 by 4th of the angle of the prism. Calculate the speed of light in the prism. So here a ray of light passing through an equilateral triangular glass prism from air undergoes minimum deviation when angle of incidence is 3 by 4th of angle of the prism. So we can write angle of incidence I equal to 3 by 4th of the angle of the prism A. So for the equilateral prism, angle of the prism equal to 60 degree. So we can write 3 by 4 into 60, that is equal to 45 degree. In minimum deviation, you know the equation R equal to angle of refraction R equal to A by 2, that is equal to 60 by 2 equal to 30 degree. Then to calculate the speed of the light in the prism, first you want to calculate the refractive index. So using the formula n equal to sin I by sin r. Here minimum deviation is not given, delta m is not given. So you can use this equation n equal to sin I by sin r, that is equal to sin 45 divided by sin 30. So by substituting the value sin 45 1 by root 2, sin 30 1 by 2. So we get n equal to root 2, that is equal to 1.414. Then we can calculate the value of velocity or the speed of the light in the prism v equal to c by n, that is equal to 3 into 10 raised to 8 divided by 1.414, that is equal to 2.12 into 10 raised to 8 meter per second. Next question. A ray PQ incident on the face AB of a prism ABC as shown in the figure emerges from the face AC such that AQ equal to AR. Draw the ray diagram showing the passage of the ray through the prism. If the angle of the prism is 60 degree and refractive index of the material of the prism is root 3, determine the value of angle of incidence and angle of deviation. So here the figure is given here. In the question itself, the figure is given. A ray PQ incident on the face AB of the prism ABC emerges from the face AC such that AQ equal to AR. So you want to complete this ray diagram by showing the passage of the ray through the prism. How will you complete this ray diagram? Here AQ equal to AR, which represents that the ray passes parallel to the base of the prism. So we can draw like this. So that is PQ after the refraction passes parallel to the base of the prism, then again it refracted outside. It passes from denser to the rarer medium. Okay. Then next you want to find out the value of angle of incidence and angle of deviation. Here the angle of the prism is given, that is A equal to 60 degree, and refractive index of the material of the prism is n equal to root 3. Then from this, that means angle of the prism 60 degree, you want to find out R, angle of refraction. For the minimum deviation R equal to A by 2, so we get the value 30 degree. So using the relation n equal to sin I by sin R, you can calculate the value of angle of incidence. So n equal to root 3, that is given in the question, then sin I divided by sin 30. So sin I equal to root 3 into sin 30, then sin I equal to root 3 into sin 30 1 by 2. So we get sin I equal to root 3 by 2. So what is the value of I? That is sin inverse of root 3 by 2. So that is equal to I equal to 60 degree. So angle of incidence is 60 degree. Then you want to find out the angle of deviation. So you know this formula, that is I plus E equal to A plus delta. So if from the ray diagram AQ equal to AR, then angle I equal to angle of emergence. So we can substitute I equal to 60, then E equal to 60. So we can rearrange the formula, delta equal to I plus E minus A, that is equal to 60 plus 60 minus 60, that is equal to delta equal to 120 minus 60 equal to 60 degree. Next question, a glass prism of refracting angle 60 degree and a refractive index 1.5 is completely immersed in water of refractive index 1.33. Calculate the angle of minimum deviation of the prism in this situation. So inside the bracket it is given sin inverse of 0.56 equal to 34.3 degree. So here the glass prism is immersed in water, completely immersed in water. So we can write refractive index of glass with respect to water, that is equal to Ng by Nw, Ngw equal to Ng by Nw. So that is Ng means refractive index of the glass, that is 1.5 divided by refractive index of the water 1.33. So we can write the equation refractive index of glass with respect to water equal to sin A plus delta m by 2 divided by sin A by 2. You want to calculate the angle of minimum deviation. Okay, so we can write Ngw equal to Ng by Nw equal to sin A plus delta m by 2 divided by sin A by 2. Now we can substitute the values, that is Ng equal to 1.5 divided by Nw 1.33, that is equal to sin A plus delta m by 2 divided by sin 30. So that is sin A by 2, that is sin 60 by 2, that is sin 30. So we can write sin A plus delta m by 2 equal to 1.5 by 1 by 33 into sin 30. So what is sin 30? That is 1 by 2. Then when you calculate this one, we will get 0.56. So A plus delta m by 2 equal to sin inverse of 0.56. So what is the value that is given in the question? Sin inverse of 0.56, that is equal to 34.3 degree. So we can write 34.3 into 2, that is 68.6 degree. Okay, so delta m equal to 68.6 degree minus A. Then we can substitute the value of A. So we will get the answer delta m equal to 68.6 degree minus 60 degree equal to 8.6 degree. That is the value of minimum deviation. Now the question, figure shows a triangular prism of glass. A ray incident normal on one face is totally reflected. What can you conclude about the minimum value of index of refraction of glass? So the figure is given in the question. It is a triangular prism of glass. A ray incident to normal on one face is totally reflected. So for the total internal reflection, what is the condition? That is, angle of incidence must be greater than the critical angle of incidence. So from the figure, what is the angle of incidence? This is the angle of incidence. This total 90 degree. So this is the angle of incidence, that is equal to 45 degree. So 45 degree, that is greater than the critical angle of the prism, that is nearly equal to 42 degree. So we can write sine on both sides, that is sine 45 is greater than sine IC. So you want to conclude that minimum value of refractive, you want to find out the minimum value of refractive index of the glass. Okay, so sine 45 greater than sine IC means it is equal to 1 by refractive index. So here refractive index of the glass. So sine 45 greater than 1 by mu g. So what is sine 45? It is equal to 1 by root 2. So 1 by root 2 greater than 1 by mu g. So we can cross multiplication mu g greater than root 2. So we can conclude that refractive index of the glass is equal to, that is minimum value of refractive index of the glass is equal to 1.414. Next question. 3 rays of light, red, green and blue, are incident on the face AB of right-angled prism ABC. The refractive indices of the material of the prism for red, green and blue wavelengths are 1.39, 1.44 and 1.47 respectively. Out of the three, which color ray will emerge out of face AC? Justify your answer. Trace the path of these rays after passing through face AB. So here 3 rays, blue, green and red, are incident on the face AB of right-angled prism ABC. So here the refractive indices of the red light is given as 1.39 and the green light 1.44 and the blue light 1.47. So you want to find out of the three which color ray will emerge out of face AC. So for that, first you want to find out the refractive index of the glass material. So here, what is the angle of incidence? The angle of incidence of these rays are 45 degree, because here the angle is 45 degree. So angle of incidence of these rays are 45 degree. So that is greater than the critical angle of incidence. So we can write I greater than IC. So this is the condition for the total internal reflection. So we can write sin I greater than sin IC. So sin 45 greater than sin IC. So we get, that is refractive index of the glass equal to 1.414. Now we can compare this with the refractive index of the red, green and the blue light. When you take the red light, refractive index of the red is 1.39. That is less than the refractive index of the glass. So if the refractive index is less, then critical angle of incidence is greater. So that must be greater than the angle of incidence. So what happens here? This condition does not satisfied by the red light. So because of this reason, the red light emerge out from the prism. There the total internal reflection does not take place. Red light emerge out from the prism. Then for the green light and the blue light, its refractive index is greater than the refractive index of the glass prism. So if the refractive index is greater, angle, that means critical angle of incidence is less than the angle of incidence. So it satisfies the condition for the total internal reflection. So what happens here? The green and the blue light will undergo total internal reflection and it comes out of the, that means after the total internal reflection, it emerges out from the face BC. Clear?